Hey guys, Mr. Backerberg here. In this video we're going to look at different ways of representing real numbers. When we're talking about real numbers, a real number is any number that can be written as a decimal. So something like -8 is a real number, 0 is a real number, 1.75 is a real number, but also fractions are real numbers. So something like 3/2 has a decimal form to it, so it's a real number. The square root of 3, we could type that into our calculator and get a decimal approximation, so it's a real number. Even something like pi, where there's not any actual numbers written there right now, but we know the pi symbol represents about 3.14, so that's also a real number. Pretty much any number that you can think of is a real number. As we're looking at real numbers, there are a few important subsets of real numbers. The first of which that we're going to talk about is the natural numbers, or some people call these the counting numbers. So just as if you were to count a number of objects, counting numbers start at 1 and just continue on from there. 2, 3, so on and so forth out to infinity, so as high as you can count. The next important subset of real numbers is going to be the whole numbers. And whole numbers are very, very similar to the natural numbers. We're just going to throw one extra element in there, and that number is going to be 0. So we're going to start at 0, and then we're going to count up from there as far as we can. Now you'll notice these subsets are gradually getting a little bit bigger. First we had the natural numbers where it was 1, 2, 3, so on and so forth, and then we added 0 in there and we got our whole numbers. Now as we look at our next subset, the integers, again it's going to be similar, but we're going to be including some extra values in this set. So we're still going to have 0, 1, 2, but we're also going to have the opposites of those numbers as well. So along with 1, we're going to have -1, and along with 2, we're going to have -2. And this set is going to extend in both directions, so we could have more negative numbers, and we could also have more positive numbers. After the integers, we talk about rational numbers. And rational numbers are any numbers that can be written out as fractions. So 1/2 is a rational number. 3/4 is a rational number. But also any of those integer values that we just talked about can also be rational numbers. So something like -4 is an integer, but we can turn that into a rational number by taking it and putting it over 1. So any integer value can be turned into a fraction by just putting it over 1. The only thing we have to be careful about when we're writing out rational numbers is we need to make sure that whatever number is on bottom of the fraction is not 0. You're never allowed to divide by 0. That gives you an undefined value. When we're looking at rational numbers, they can also be written out in their decimal form. So 1/2 as a decimal is 0.5, or 3/4 as a decimal is 0.75. There's two types of decimals that we can have when we're dealing with rational numbers. The first kind of decimals are called terminating decimals, which is what we're dealing with 0.05 and 0.75, a decimal that stops. But we also have infinitely repeating decimals. So something like the fraction 4/11 has an infinitely repeating decimal. If we were to type this into our calculator, we'd get 0.0363636, and it would just keep continuing on like that. Okay, that's a decimal that repeats itself an infinite amount of times, which is why we're calling it an infinitely repeating decimal. There is a shorter way for us to write this though. Anytime we're dealing with a repeating decimal, we can take the portion that's repeating, so in this case the 3/6, we can write that out and put a bar over the top of it to show that that value keeps repeating itself. So let's look at an example where we examine the decimal forms of a few different rational numbers. The first rational number that I want to take a look at is 1/16, and that fraction bar means divided by, so really this is 1 divided by 16. If we were to take that and type that into our calculator, we would get 0.0625. That decimal stops after the 5, so it's terminating. The next rational number I want to take a look at is 55 over 27. So again, that means 55 divided by 27. If we were to take that one and type it into our calculator, we get 2.037037, and that continues on. We can see that there's a repeating portion of our decimal, so we could shorten this to say 2.037, and we put the bar over the 037 since that's what's repeating itself. So that's an infinitely repeating decimal. There are some limitations as to what our calculator can show us, though. If we look at the fraction 1 over 17 and try to type that into our calculator, we get that big long string of decimals that I just wrote out. Now, there's actually not enough information there to tell us whether this decimal is repeating or if it terminates, and we would need to include more decimals than are available to us in order to make that determination. This actually is an infinitely repeating decimal. Like I said, we do need to extend that out a little bit further to see the piece that actually repeats itself, but it's that whole big long string of decimals that I just wrote out in red. That's the repeating portion of this decimal. There's one more subset that we're going to talk about, and that's the irrational numbers. Irrational numbers are any numbers that are not rational, so numbers that cannot be written out as a fraction. So something like pi is an irrational number. When we're looking at the decimal versions of irrational numbers, these decimals will never terminate and they will never repeat themselves. So pi as a decimal, we know that it's about 3.14, but there's a lot more decimals than that. From there it goes 1, 5, 9, 2, 6, 5, and it keeps going on and on from there. Okay? This is an irrational number, so like I said, that means that this decimal never ever stops, it never terminates, and it also never repeats itself. So a lot of times when we're dealing with irrational numbers, we'll use a different symbol to represent those. So that's why we use the pi symbol to represent this big long decimal. But also something like the square root of 3 is an irrational number. Now we can approximate that as that decimal, but again, it keeps going on and on forever without stopping and without repeating itself. So a lot of times, instead of writing out that big long string of decimals, we'll just leave it written as the square root of 3. That's going to be it for this video. Thanks for watching.